All right, let's dive into a really fascinating case study today. We're looking at an experiment that took a powerful tool, the Wiki, and dropped it right into a middle school classroom. It's a great story about the promise of technology in schools, but also, the real-world hurdles you hit along the way. The lessons here are absolutely crucial. So let's get into it.
I mean, you see it everywhere, right? Today's students are for sure digital natives. Outside of the classroom, they live in this constant whirlwind of communication, texting, sharing, creating stuff together online. It's why they've been called the great communicators. They're not waiting for instructions on a new app, they're just figuring it out. But what happens when that world collides with the world of school?
And that, right there, is the big question for modern education. Is the classroom actually keeping up with how these kids already live and learn? This gap, between how they use tech at home versus what they do at school, that's what people are calling the digital disconnect.
So how do you even begin to solve a problem like the digital disconnect? Well, one group of educators came up with a project to try and bridge that gap, using technology to get students to tackle a really complex, real-world issue.
The project was called Under Control, and it was pretty ambitious. It asked a bunch of middle schoolers to dig into the impacts of damming the Missouri River, a huge, controversial issue happening right in their backyard. The goal wasn't just to have them memorize facts. It was to get at something much deeper, critical thinking and actually solving problems together.
Now, to get a bunch of kids from different schools working together, they needed the right tool. And the tool they chose for this big experiment was the Wiki.
You've definitely heard of Wikipedia, but what is a wiki, really? Well, think of it like a shared digital whiteboard. It's a website that's designed from the ground up for collaboration. Anyone with permission can jump in, add things, change things, and build one collective document together. It's always a work in progress.
And this is what makes it so different from, say, a blog. With a blog, right, you have one person writing and everyone else is just in the comment section. A wiki is the total opposite. It's a shared canvas where the final thing you see is this blend of everybody's work.
For this project, they used a specific software called Twiki, and they picked it for a few key reasons. First, it let them create a private, locked-down site, which is super important for student privacy. Second, it kept a log of every single change, a full revision history. And third, and this is going to be important later, it had a page locking system so two people couldn't edit the same page at the same time. Okay, so they had the project idea, they had the tech, but now came the really tricky part. How do you organize hundreds of kids across a bunch of different schools? This was a huge logistical challenge.
And when I say huge, I mean it. We're talking about nearly 400 students. And they weren't in one building. They were spread out across 11 different schools in different places. Just coordinating that alone was a massive job.
So, to manage all that, they came up with this really smart structure. First, they put all the students into 4 big teams, mixing kids from different schools together. The idea was to get different perspectives. Then, inside those big teams, they created small research groups, just 4 to 6 students each. Every little group got their own specific topic, like water rights or habitat loss, and their very own wiki page to work on. The structure was set, the kids logged in, and the project kicked off. But as anyone who's ever been in a classroom knows, even the absolute best plans run into, well, reality.
And when they looked back, the hurdles they faced pretty much fell into 2 big buckets. On one hand, you had instructional issues, problems with, the teaching and learning part. And on the other hand, you had technology-related issues, just practical problems with the gear and the software.
Almost immediately, that first week, a big instructional problem popped up. The posts from the students were, well, they were pretty basic. Just simple statements of fact like, dams stop floods. There was no debate, no one building on anyone else's ideas. It just wasn't the rich, deep discussion they were hoping for.
And one of the teachers involved just hit the nail on the head. She said students are just so used to looking for the right answer to a question. The skills they needed for this project, like really digging into research and asking tough questions, it just wasn't something they normally did in school.
And a couple of other things made it worse. For one, the students were treating the wiki like it was instant messenger, expecting quick, short replies. And at the same time, the teachers, who were also new to this, weren't really jumping onto the wikis to model the kind of deep questioning they wanted to see. And then you had the tech problems. Remember that page locking feature? Well, it turned into a huge bottleneck. It meant only one kid in a group could type on the wiki at a time, leaving everyone else just sitting there waiting. Add to that the fact that some schools had to fight for time in the computer lab, and other schools had tech that was flat out broken with nobody to fix it, and you've got some serious roadblocks to collaboration.
But here's the thing. The story doesn't end with a list of problems. No way. In fact, the most valuable part of this whole thing was what the educators learned from all these challenges. So let's look at the lessons they pulled from this because they're really insightful.
So they put together a really clear plan to improve teacher training next time. First, the project leaders themselves were going to get on the wikis and model how to ask those deeper, critical thinking questions. They also decided to open up editing access earlier and get teachers to post student drafts sooner, all to encourage that real back-and-forth collaborative writing. And what about that super frustrating page locking problem? Well, the teachers who had the most success figured out this brilliant, totally low-tech solution. They just put the kids into small groups around a single computer and gave them jobs. One person was the wiki recorder who did the typing, and another was the discussion facilitator who kept the conversation going. It was a teaching strategy that completely solved a technology problem.
And really, that's the big takeaway from this whole experiment. Technology isn't some magic wand you can wave in a classroom. Just dropping a new tool in front of kids doesn't automatically lead to deeper learning. What really matters is the thoughtful instruction, the support for teachers, and the clever strategies for managing these new digital spaces. Which kind of leaves us with a final big question to think about. Are we looking for technology to be the solution? Or are we ready to do the hard work of reinventing how we teach and the new kinds of classrooms technology creates?